nutrients regulations, nutrient cycling, waste treatment, biological control, habitat, food, raw materials, recreations, cultures, etc. Okay, and this amount to the annual production, 20,000 billion US dollars every year. Okay, it's a huge number. Okay, of course these are not commercialized. You don't really, this is some estimate made by economists. Okay, economists likes to put numbers on, put dollar signs on everything. Okay, and I like that as well. So how big is this? This is actually all the number I find on Google. If you Google how expensive is Google, and then you get these numbers. That roughly 30 to 40 million US dollars. Okay, the price of Googles. So if so, the all fishermen, if they get together, they can buy several Googles. Okay, so how about Taiwan? Well, small countries. The scale is not, like quite large, but that's a value I obtained from government report in 2005. I should have updated this, but I don't have time. The annual production in 2005 is 90 billion New Taiwan dollars. Okay, so that's the value that you obtained when fishermen trade their fish with some company at a fishing port. Okay, only at a fishing port. Okay, it's not at a supermarket. Okay, so if this big company, they take a fish and they sell to the supermarkets, and then you guys buy the fish, then that's called retail price, right? So the retail price in the market is probably multiplied 3 to 10 times. Okay, depending on condition. So conservative numbers, it's maybe like $300 billion production per year for Taiwan fisheries. This is a very huge number. Okay, Taiwan is a small country, but fishery production is huge because we catch a lot of tunas. Taiwan is the second biggest tuna fisheries country in the world. First one is Japan. Okay, and we are second. So that's how we can get so big money. And all the fish, most of the fish sell to Japanese. So anyway, let's just give you some motivation of why we care about oceans. So the outline for today, I'll talk about the pelagic ecosystems, mostly the environment around Taiwan, and I also mentioned about some research, some real ongoing scientific research around these areas. And I talk about fisheries and seafood, and then come back to consider a little bit on overexploitation, the overfishing problem, and how we should care about the conservation. Okay, so since you are not, I assume you are not familiar with pelagic ecosystem, so I give some introduction about all kind of diversified life in marine ecosystems, and then I go into detail to discuss all these different environments. Some are written in Chinese, but almost all of them have English next to it, so I hope this is understandable. So the marine environment can be divided into zones. Okay, in the vertical zone, you can divide into epipelagic. It's about the surface up to 100 or 200 meters, and then mesopelagic is about 1,000, and basipelagic about 4,000, and then down to the bottom. Okay, that's just a name that marine scientists try to define different zones, because in different zones there are different kind of chemical and biological and physical processes, and we will gradually discuss this a little bit. From a horizontal point of view, you can see, okay, very close to a shore, there's an intertidal zone, right? But sometimes it's covered by water, sometimes not. And then you have a neritic environment. So neritic means this area is constantly affected by the coastal region. It's called neritic. Okay. And then oceanic area is an area really far away from the land. So it's not really affected a lot or in a short time scale, not affected a lot by the land. If you see the bottom, you can see again, it's an intertidal zone. You have a subtidal zone. You have a strafe break, a basal, header. But this is just names, so maybe not very critical. This is just a beautiful picture of the same thing. Okay, you can see a different kind of organisms living in different environments. Okay, so here you find different kind of organisms living in different environments. You have a phytoplankton, so that's a plant living in the ocean, the primary producer. Okay, they make food, they take sunlight, convert it in energy and make food. And then zooplankton are also very, very small organisms. They don't have a swimming ability, so they will go with the flow. Okay, no matter how the flow goes, they will just go. Those are the definition of plankton. So plankton is organisms living in the water that don't have a strong swimming ability, so they cannot counter the water. Okay, and then you have a fish nekton. Nekton means that like fish, squid, turtles, they live in the ocean. They have a strong swimming ability. They call it nekton. Of course, the nekton will eat zooplankton, and zooplankton eat phytoplankton, something like that. And in benthic, you have coral reef. You have a different kind of benthic. They have sea star, sea cucumber, sea urchins, barnacles, a different kind of benthic animals. So the ocean, the organism living in the ocean will also classified according to size. Okay, the small one is very small, 0.2 to 2 micron. Okay, well, 1 micron is 10 to the minus 3 meter. Okay, it's small. So it's bacteria, and getting larger, you have a protist. Okay, very tiny unicell organisms. Okay, and getting bigger, you have diatoms. That's phytoplankton. You have ciliate, dinoflagellate. It's all very small animals. And you have getting bigger, you have a mesozooplankton. You have crustacea. You have a jellyfish, something like that. And you have a macro zooplankton. You have a shrimp. Okay, and there's a jellyfish. Okay, bigger ones. Sometimes some jellyfish can be very, very big. Okay, then you have mega zooplankton. This is classified according to size, and the size is very important in terms of biology in the oceans, because in the oceans typically the big eat the small. Okay, big fish eat the small crustacea. Crustacea eat even smaller phytoplankton. So size determine very much about who eats whom in the ocean. Okay. Just some common introduction to phytoplankton. The name is probably not very critical. Just show you a different kind of shape. Okay, some are elongated. Some form a chain. So each one is one cell, but they form a chain. Some have this flagellate. Is like a tail, so they can help them swim. Okay, so they have a different kind of shape due to a different evolutionary consequence. And I mentioned the zooplankton will eat phytoplankton. Okay, and that's this guy. This kind of organism is called a copepod. Okay, it's a kind of crustacean. It's very small. Around in the oceans around Taiwan, there will be between 0.5 millimeter to 2 millimeter. Very small. That's just their life cycle, and they comprise 70% of the total zooplankton biomass. So they are the most important organisms. One of the most important organisms in the ocean. There are other guys called a meroplankton. Meroplankton means the plankton that have spent only part of their life as a plankton. For example, fish, when they are baby fish, they don't have swimming ability, so they are part of plankton. But when they become adults, they have a swimming ability. They are no longer plankton. Okay. So for example, some larvae, some juvenile of barnacles. Okay. When they are juvenile, looks like barnacle. Okay, so they are like plankton, like a small tiny crustacea. But they become adults. They settle onto the bottom, and then they are no longer pelagic. So then these are figures showing some adaptation of plankton. So you can find typically they have a spine. Spine is a very main spine. Main spine. Okay, then questions. Have some guess why do they have spines? Why plankton need to have spines when they live in the ocean? They have spine. Any guess? Get more water. They live in the water. I believe they probably don't need more water. It's not straw, okay? It's not trying to suck up water. Okay, it's good guess. Yeah, it's a very good answer. Stop predators. Okay, so because they have spine, okay, some defense mechanisms. Okay, they stop predators. Okay, another important mechanism is for floating. Actually, so if they have this fine city, they spray out. Okay, then they have they create some tension. Okay, so they help them to float in the ocean. Okay, because they are plankton, they don't want to sink down actually. Okay, so they keep them stay at some particular depths. Okay, so floating mechanism as well. Defense and float. Yes, question.
Is there anything in the ocean that is a hybrid of an animal and plant?
Hybrid of animal and plant. Hybrid. What do you mean by hybrid? Have a characteristic of both plants.
It can swim, it can eat, but also can do food.
Oh, okay. Yes. We don't call it hybrid. Okay. Yeah, we call it. Yeah, hybrid sounds like animal. We have sex with plant. Sounds a little strange. Okay, that's kidding. So we call it mesotrophic. Mesotrophic means they have an ability to do photosynthesis, but they also simultaneously have an ability to eat other things. Okay, they call it mesotrophic. It's actually very, very common for this size organisms, like called protists. Okay, they're unicellular, only one cell. Many of them have a chloroplast, chloroplast, so they can do photosynthesis. They take energy from light, but they can also eat smaller bacteria. They can eat other similar size plankton. Okay, so they call it mix, mesotrophic. Okay, they have ability to it. And even some interesting guys, they themselves they don't do photosynthesis, but when they eat phytoplankton, they eat plant, they take their chloroplast and keep it there in their body, and they use the chloroplast to do photosynthesis. Okay, and they simultaneously eat other things. So they are, a sort of alien style of living life. Okay, they can steal other organisms' chloroplast to do photosynthesis. So they have to keep eating other phytoplankton. So because the chloroplast, they cannot produce chloroplast, and chloroplast cannot last for too long. So when the chloroplast is too old, they have to digest them and eat new chloroplast. Okay, so that's a good question. Okay, so hybrid, yes, hybrid. Okay, in the ocean you also find a sort of jellyfish, ctenophore, another kind of jellyfish, and these are jellyfish. And you also even find some shrimp-like organisms. There's another jellyfish, and that's sort of squid. One characteristic is transparent. Okay, many of them are transparent. Another, okay, guess why? Why they are transparent? Why organisms living in the ocean likes to be transparent?
Camouflage.
Say again?
Camouflage.
Camouflage? Yeah, it's good. Yeah, actually, sort of good answer. They're transparent, so other predators don't see them. Okay, yeah. So camouflage. Yeah, sort of. That's the most important mechanism. So to avoid predator. Okay. So in practice, when we try to study them, we often we can use camera watch them. Okay, of course. Now we have really good technology, you can watch them in the water. But for a lot of time, we collect them and just study them in lab. Okay, so that's a typical plankton net like this. And I have a plankton net here. You can take a look. Plankton net like this. Okay, it's almost identical to this height. It's called the North Pacific Standard plankton net. So please show a little bit respect to it because it helped me a lot collect many samples when we are in research cruises. So this is my body, okay? This looks like not so great, but it actually is yes. Okay. One piece of these things will cost $30,000. Okay. Because the mesh is very fine and very durable in the water. Okay, durable. But when you have dry project, so I can test this to you, but don't try to check how durable it is. Okay, don't try to, okay, maybe not so durable. Okay? When it's in the water, in terms of the water, the tension between water and the net is good, but water is not like human. I believe you can tear it apart. I am not going to let you try that. So we have some weight here, so help to push this down to the bottom to the water. So that's called cut end. So you can screw this in, okay, and then when you collect the animals, you just take this out and put a cap again and bring this back to your lab to do whatever you want. And also, when you do the collection, it's very important to figure out really how much water you filter through, because we need to count, how many animals per unit of whatever, per cubic meter, for example. So we really need to calculate how much water passes through it. So we use this like it's a counter. It's called flow meter. So when water passes through, that's doing like this, and then there's the numbers. Okay, and we have calibrated the coefficient. So with these numbers, and you can know how much water passes through, and then you multiply with the size of this mouse. Okay, this area, then you can calculate how much water passes through during your experiment. Okay, so what we did, I can put this on. So we did, we have these shuttles, so we can just put this onto this net. Okay, so that's our net. So when you tow with on ship, okay, it looks like this, okay, and then you tow to the water, and then this will keep turning, okay, and there is only one way turn is there resistance there, so you do not turn back, okay, do not turn back, so you don't do the miscalculation, okay, so and also these tiny things, it will worth more than $20,000 per each. Then this is very fragile, so when you check it, so please be careful. Okay, I can test it through. You can take a look at it. No problem. So things very nice. It's very simple, but if you want to do things right, you have to be careful about many things. So actually, not so cheap. Then we go out to fish, plankton, netten, sorry. So they have a swimming behavior, okay, it's called a netten. Also, there are all kind of fish, fish, and turtle, also called part of netten because they have swimming behavior. That's a migratory route. About green turtle, that's an endangered species. Okay, and I mentioned before you can divide the ocean into different depths. Okay, and now I will talk a little bit on the biology of this fish living in the mesopelagic and the deep ocean. The fish that live in the deep deep area, they have a very limited light, the twin light zone. Okay. Okay, that's the fish living in the very deep water when they are not too much light. Okay, they looks very strange. Some, I think they are cute, but some people think they are ugly. Okay, that just depends in how you see things. Disgusting? Well, yeah, some people probably think that. Well, I'm sure that you don't want to eat them.
Like zombie fish.
Zombie fish? Okay. So one characteristics, important characteristic, they have called a Bristol mouse. Okay, the mouse is very huge. Okay, and they have a very strong teeth. Okay, there's one characteristics of a fish. Usually mouse is a big part of their whole body. Okay, mouse is like this, maybe 1/3 of their body. Okay, and many of them have bioluminescence organs. Okay. Okay, all right, question. So, yeah, okay, go ahead.
If they cannot see, why they have eyes?
They can see. There's a twin light zone. They depending on how deep they are. Some really completely lost their eye almost. But these guys probably live in the a little bit not so deep air region, so there's still light. Okay, so there are different kind of adaptations. So if there's still a little bit light, what should you do? You should have a big eye, right? But if there's completely no light, what should you do? You just close your eye, right? Okay, so anyway, evolution has a consequence. They're not smart. They are not stupid. Okay. And then they have a bioluminescence. Okay, there's flashing lights. Why they flashing lights? In the there's not too much light in the region, but they still flash, make some bioluminescence. Why? What's the purpose? Got food. Yeah. Exactly. Attract stupid other anything. Okay, they can attract other plankton, attract other small fish. Exactly, they're attracting other fish. Okay, they can, so they can catch their food. So there's also deep sea shark. I'm not very familiar with this. So there's all different kind of fish living in the very deep environment. They have a big mouth like this. Most of them have very big mouth, very strong mouth, and some have this. This is called anglerfish. They have a this is called a lutein fish. They have flashing here. They have bioluminescence here. Okay, again to attract. It's like a fishing. Okay, the fish is doing fishing. Okay, they attract other fishes to come and eat them. Okay, there's some preserved sample of anglerfish. Okay, they all have such kind of thing. Okay, so this figure summarizes all kind of adaptation that the deep water fish have. They all have a bigger mouth. Okay, why do they need to have a bigger mouth? Because what?
They are waiting for the
they cannot see. Okay, yeah, that's part of it. What else? Yes, go ahead.
It's not that they are opening their mouths and they are waiting for the food from coming? No?
Part of it, some fish actually do that. Anything else? Well, that's all correct answers. They have a big mouth because in a very deep ocean, there are not too much food. Okay, food usually in the very surface layers in the deep ocean. So they have a big mouth. If they find anything, they want to swallow it. Okay, they don't want to take a bite, and then the fish just drop it to the bottom. They never find it because there's no light. Okay, they can never find it in their entire life. So they don't want to take a bite and they just let it go. Okay, they want to swallow everything they can. Okay, some fish can even swallow almost the identical size of it itself and just keep it in the mouth and chew them. So because they may swim in the water for days without encounter anything. Okay, so once they encounter anything, they just want to swallow it. So they need a big mouth. Okay. They usually don't have a very strong swimming ability. Okay, and they don't adjust their floating position very much, so they have a very small swim bladder. Okay, but usually they have some these things to attract other organisms. Okay, so that's an adaptation of these deep water fishes. Okay, so I try to put the things together. So you have a very small phytoplankton. Okay, that's the primary producers. They convert the sunlight energies to carbon. And then you have small crustaceans, copepod, shrimp, krill. They eat the phytoplankton. And then, of course, you have a big fish. They are eating this zooplankton. So this is structured according to size. Okay, roughly according to size. The small to big. So big is small. Yeah, go ahead. This one. Yes, it's possible. The baby fish can be eaten by some other jellyfish and even arrowworms. Okay, because they have a big mouth, and jellyfish can be big. Okay, jellyfish, depending on species, some are tiny, some can grow up huge, like this rune size. Okay, so yeah, so you can see that interesting phenomena that for fish, when they are babies, they are other predators' food. Okay, but when they become bigger, they become predator. Okay, so that's called ontogenetic change. So they change their role in the food web when they are small and when they are big. Very different. Okay, it's also very common for fish to eat their own baby. Okay, very common to eat their own baby. Okay, it's actually very common in the ocean. All these krill, all these copepod eat their own eggs and eat their babies. Okay, because they are usually not so selective. They don't have very strong selectivity. It's not like human. They can see, check and eat. Usually they eat whatever they encounter. Okay. Any question before I move forward? Okay. And then I continue to give you some examples of different marine environments around Taiwan, and I will talk about some related research that will carry out recent years around in these regions. So that's Taiwan, and you have the East China Sea, that's Pacific Ocean, South China Sea, and Taiwan Strait. First, to study ocean, we need to know how the water flows around Taiwan. So these are different kind of main current around Taiwan. Okay, so on the eastern part of Taiwan, it's called Kuroshio. Okay, Kuroshio is a very strong current. They flow from equator and up from eastern part of Taiwan into Japan. Okay, it's called Kuroshio. This current have a branch. They will move into Taiwan Strait. It's called a Kuroshio branch current. Okay, there's a Taiwan and Philippines, and there's a gap here, so the water can flow into this region. So that's a south-northward flowing. And also part of South China Sea, water can also move in. Okay, if the wind is blowing this direction. From the northern part, we have a very strong, in winter we have a very strong, it's called a China coastal current. Okay, this is formed because there are many big rivers around China coast. and all this fresh water flow into the ocean. And when the northeastern monsoon is very strong, they will blow this fresher water, cold water, downward. It's called China coastal current. So I will introduce different regions. Northeastern Taiwan is upwelling ecosystem, and Taiwan Strait is a continental shelf, and East Taiwan is cross-shore ecosystem, and South Taiwan is deep South China Sea system. I will not talk about the basic ecosystem. Okay, so starting from the northeast Taiwan is the upwelling system. Okay, so everybody understand what's upwelling? No? Okay, upwelling means the water coming from the deep layer up to the surface. Okay, why upwelling is important in terms of biology in the oceans? So let me try to explain. So we mentioned the phytoplankton, they take up light energies, right, and convert it into carbon. So they need light. Okay, so most of phytoplankton live in a very shallow region, very surface area, because they need light. If they're going deeper, there's no light. Okay, so they cannot have energy. So they need in the shallow. But the light is not the only factor determining the growth of phytoplankton. They need also nutrients. They need food in addition to light. They need to suck up different kind of like phosphate, nitrate, different kind of molecules, chemicals. Okay, they need to suck up different kind of chemicals. Okay, and the chemicals can provide as food, so they can convert energy, sunlight energy, into food, into carbon. Okay, so typically in the ocean, in the surface layer, you find almost no these nutrient chemicals. Very difficult to find nutrient chemicals. Because of what? What? Say it again? Gravity? They are dissolved, so they probably not a very big issue. Well, the reason you don't find a lot of these chemicals is because phytoplankton eat them up quickly, very, very fast. So the phytoplankton, they can grow very, very fast. So if they have sufficient sunlight and they have sufficient food with all different kind of chemicals, they will take out these chemicals almost immediately. Okay, so when we scientists try to measure chemicals, we almost measure nothing. So okay, now you say, well, now there's no food because all these phytoplankton suck up everything. Okay, there's no food. So there must be some supply in order for the phytoplankton to grow. Okay, if they suck up the food, there is no food, then they will die. Okay? So the food, the chemicals must come from somewhere. They can come from the air, but very limited. Okay, maybe sometimes raining or some dust. They will fall onto the ocean and they have some food. But mainly the food comes from the bottom. Okay, from the bottom, because the phytoplankton, they take chemicals in the surface layer, but they don't go to the deep area because there's no light. Okay, so there's always about high amounts of chemicals in the deep layer. Okay, they're not utilized by phytoplankton. So if by any chance, by any weather event, this deep water, they can come up to the surface. Okay, then they bring up this nutrient again, and then the phytoplankton can utilize these chemicals, and it actually happens very, very often in the ocean. So there must be some physical mechanisms that can bring up the nutrient. Okay, so that phytoplankton can use this nutrient. Okay, there are many mechanisms. For example, the weather, the wind blowing. Okay, the wind blowing, they will make a bigger disturbing in the ocean, so they will bring up some nutrient. Okay, so the most typical mechanism is the wind that can bring up nutrient. But in this region, there's a very special mechanism that bring up nutrients. no need for wind. Okay, so that's why this is a very interesting region. Okay, so I explained already that's crucial in the eastern part of Taiwan. Okay, but in the eastern part of Taiwan, is typically very. Let me show you some data picture. Not going down to the next. Okay, that's better. So that's the topography of this region. Okay, here is very, very deep, more than 100 meters, more than 1,000 meters deep. Okay, but this region is very shallow, about 200 meters shallow. Okay, so you imagine the water going from here to here. Suddenly, originally they are very deep. Suddenly, become very, very shallow. Okay, sudden change of this topography that bring up a lot of deep water onto the surface. Okay, no need for wind. Okay, when they bump into this like sea mountain, okay, or this continental shelf, okay, it's like they hit this shelf, they have to go up. Okay, so a lot of nutrient was brought up by this physical mechanism without wind blowing. Okay, and this happens year round because crucial is a very strong current that goes this direction all year round. Okay. So this is just showing the flowing direction, okay, and this is the topography. So the water move into the bump into the continental shelf and bring a lot of nutrients. As a consequence, this color coding represent the different production, okay, phytoplankton production, okay. So you can see in this particular region where the crucial hit the bump into the continental shelf, become the operating. They bring a lot of nutrient, and therefore they have many phytoplankton production. Okay, so that's experimental survey result. You can see in this particular region, they are very high phytoplankton production, and then they disperse, both sides, so they, gradually decline. Okay, so this is a very interesting region that caught a lot of attention internationally. Okay, in the world, very few places like this. And what happens when you have a lot of food, a lot of phytoplankton? Okay, of course the zooplankton are happy because they eat this phytoplankton. And then who will be happy? Fishes will be happy. Okay, because fish eat a lot of zooplankton. And then who will be happy? Us. Yes, we will be happy. Yeah, we are. I think they are. Well, they are so happy because maybe they're tired. But when they come to the catch, they're probably very happy. Okay, so these are macros that caught around this region. So every year we have a very good fisheries around this region. The macros in Taiwanese Qingyu, okay, Qingyu. Japanese Saba. Japanese also catch many such kind of fish. Okay. So that's a very important fishery. So these fishermen probably never study ocean around Taiwan. They probably never know how they can catch so many fish. Okay, so they should all come to my lecture. So I explain to them that the reason you catch fish is because you are really lucky, because you are working really hard. All right, let me continue to explain a little bit about the Taiwan Strait before we take a break. So that's again the topography of Taiwan Strait. So topography is very important. Okay, so when you study ocean. So there's a Penghu Island. Everybody been to Penghu? Anyone been to Penghu? No? Oh, it's pretty. Oh, you should go. Not in this season though. It's very cold. But in summertime, it's a very nice place. Okay. Many coral reefs, many reef fish. You can do scuba diving, you can do snorkeling. Very, very nice weather, very, very nice place. Okay, but don't try to kill corals. Okay? Don't try to catch fish. You can enjoy it. Okay? It's a very, very good place to go. You can take either a plane or take a ship here. Not very expensive. So maybe that's your plan for the next summer. So this region is called the Penghu Channel. It's very deep. The all Taiwan Strait is very, very shallow, shallower than 100 meters. Okay, very, very shallow. In the old time, in the glacial time, it's deep. Okay. So when the sea level is not so high, it's all deep together. Okay. So you can find many fossils in this region, like elephants or cows or different horses. Okay, many fossils. Okay, so this is but this is only a region that is very, very deep. Okay, it's called Penghu Channel. So then I try to explain the circulation and seasonality of this circulation. So different water that move differently in different seasons and mostly controlled by the monsoon. Okay, the weather of Taiwan is mainly controlled by monsoon system. So in the winter time, the northeast monsoon is very, very strong. Okay, the wind is very strong. They bring in this cold, fresh China coastal current. Okay, this current mainly contributed by the rivers runoff from mainland China. Okay, they are very, very cold. Okay, so when the monsoon is very strong, they go into Taiwan. However, there's always this called cross-shore branch current. Okay, I mentioned about cross-shore going east part of Taiwan, and one branch will flow into Taiwan. Okay, this is called a cross-shore branch. And cross-shore branch will bump into the China coastal current during this time. And during the spring, when the monsoon become not so strong, so the China coastal water become very weak. So the cross-shore water will move into Taiwan Strait. Okay, and then during summertime, when the southwest monsoon is very strong, okay, then the whole water is typically from south to north. Okay, maybe from South China Sea or maybe from cross-shore, they move into the Taiwan Strait. And then during the autumn, when the northeastern monsoon start to blow again, then the China coastal current comes in again. So it's year round, every year this pattern just repeat every year. And this kind of pattern are very important for migration of fish. Okay, so many fish, they have a migratory behavior. They eat and grow in some place, but they like to spawn, they produce egg, and let the babies grow in the other safer place. Okay, so many fish migrate. Okay, a lot of fish migrate from Eastern China Sea to Taiwan, and they take advantage. Evolutionarily, they take advantage of this China coastal current. Okay, during this time, they take the China coastal current, come to Taiwan and spawn around Taiwan. Okay, and then when they grow up, they will take this cross-shore or some other currents goes back to Eastern China Sea. Okay, the most notable fish is called anchovies. Okay, maybe you can buy the burahi. Okay, you have heard about burahi. Okay, very tiny fish. Come with a pack, and many small. Like they look white. They're actually transparent when they are alive. But if you fry them, you cook them, they become white. Okay, delicious, but Japanese like that a lot, and Taiwanese like that a lot. Burahi, okay. And burahi actually is a mixture of many kinds of species. But the main species is called anchovy. Okay, and the anchovy particularly perform such kind of annual migration pattern, and they are controlled by this seasonal variation of this circulation. So when you eat the fish, you need to think about more. Maybe next time you eat fish, you see how hot their parents bring them to Taiwan, and you just suck them with one mouth. Okay. Okay. This is called tidal eclipse. So the circulation around Taiwan is not only controlled by monsoon, it's also controlled by the tidal currents. Because when tides comes in, because this is like a channel, okay, this is like a channel. So when tide comes in, the water just goes in like this. When it goes out, it's like doing like this. So this is actually very, very strong. So tidal force in Taiwan Strait is very, very strong. Okay, I will stop here, and we take a break, and then we come back at 10:30. Okay, before then, any questions? Okay, as I guess no questions.